Lesson 23, the unit vector and vector applications. In this lesson, we're going to be focusing quite a bit on the vector applications, cases where we can take a realistic problem, structure it with vectors, and solve using properties of vectors. However, we are also going to demonstrate what are called unit vectors in this lesson. A unit vector is a vector that has a magnitude of 1. The unit vector of a particularly known vector v, which we denote with v with a little caret on top, or hat, is the vector that has a magnitude of 1, but shares the exact same direction as the vector v. So, to find the unit vector for v, what you need to do is to take the vector of v and divide it by its own magnitude, which is equivalent to taking the vector v and multiplying it by a scalar of 1 divided by its magnitude. When you do that, if we consider a vector in its polar component form, a vector in polar component form would look like its magnitude times the vector, or multiplied scalar with the vector cosine of theta, sine of theta. And if you divide the vector by its own magnitude, that is going to divide that scalar by itself, or cancel it out. All you will have remaining is a vector defined by cosine of theta and sine of theta. And when you have values of just cosine of an angle measure and sine of an angle measure, then you are going to get ratios that fit within the unit circle, i.e. a unit vector, something that fits within a unit circle of radius 1, so therefore it has a magnitude of just 1. So that's how you can find a unit vector for any given vector. However, unit vectors are also relevant because we have another way that we can write a vector, and that is considering what are called principal unit vectors. The vectors I and j are considered to be what we call principal unit vectors, where I is the principal unit vector 1, 0, and j is the principal unit vector 0, 1. We can then let v be any vector with components v1 and v2, and we can rewrite v using those principal unit vectors. What that would look like is if you write v instead as the first component of v times I, or times the I vector, plus the second component of v times the j vector. Here we are essentially treating v1 and v2 as scalars on the vectors I and j. If you think about what this would look like then, this is taking, mathematically, this would be taking v1 and multiplying it by the vector 1, 0, plus v2 times the vector 0, 1. If we distribute those scalars into each of those principal unit vectors, we will get v1, 0 plus 0, v2. And when you add those vectors by combining the first components together, that will give you v1 plus 0 is just v1. And then the second components together, 0 plus v2 is just v2. Meaning we have another way of writing a vector. There are some advantages that writing it in this principal vector format would have, or what we call principal vector decomposition. However, it more tends to be applied in certain sciences, particularly when dealing with electronics. You tend to see electronics and a lot of sciences use vectors in I and j format instead of its component form. The math with these are going to stay roughly the same. However, some also prefer to work with I and j, as it tends to act very similar to variables when talking about, say, x and y in a Cartesian equation, When you start to combine values of I, you can combine them similar to adding like terms. However, some of the other operations we will see in the following lessons, you do need to be careful about them as they tend to be structured more directly with component form. And when they're in principal vector decomposition form, well, it may look a little bit different. However, when answering questions involving vectors, if the question does not specify a format, we would typically accept vectors in either form. So if you prefer to write, for example, a vector 2, 3 in that component form, and that is your answer, that should be okay. But if you prefer to write this in unit vector form, which would look like 2i plus 3j, this is also okay.